So 36.2 has to deal with energy budgets. And we're familiar with this concept of budgets. Let's say you told your parents, hey, let's fly out to Paris for the weekend and stay in a 5-star hotel. What are your parents going to say? No. Why? Because that is celebrity kind of spending. We don't have that kind of money, right? And so all species have an energy budget and must balance energy intake with their use of energy for metabolism, reproduction, parental care, and energy storage. Because all of those things are factors in surviving and reproducing. So we say the ability of an organism to survive and reproduce. When we're talking about survival, well, the longer it survives, the greater the chance it reproduces, and depending on the species, the greater amount of opportunities it has to reproduce. And reproduction is the act of physically producing the offspring, but also ensuring their survival. And so all of those things come together so that different species have different evolutionary strategies in maximizing their ability to survive and reproduce. Fecundity is how many offspring could be produced if an individual has as many offspring as possible. In animals, fecundity is inversely proportional to the amount of care given to an individual offspring. So, for example, humans have pretty low fecundity, right? If somebody has 10 kids, that is a lot of kids, right? Even in very, very old times, like prehistoric times, fecundity of humans is pretty low. One human being cannot have that many kids. And if you told your parents, you know what, I think you guys should have more kids, you thought they said no strongly the first time to the going to Paris thing, right? They're going to say even more strongly this time, what? No. Why? Because more kids means more work, right? And more money, and effectively more energy of their lives, right? And the more kids they have, the less they can put into each individual kid they already have, right? If I have 1 or 2 kids, there's a lot more money and effort that can go into 1 or 2 kids than 15 kids, for example, in terms of per kid. That's just the reality of it. So some species produce many offspring, with each offspring bearing a lower chance of survival. So think about a plant that releases all the seeds. The chance that any one individual seed becomes the full-grown plant is pretty small, but the evolutionary strategy there is that there's a lot of seeds dispersed. Whereas some species produce few offspring. So a coconut, there's a lot more energy per seed, but because there's a lot more energy in the individual seed, every individual seed has a much greater chance of actually making it to adulthood. Plants don't become adults, but maturity, right, where it can then have a greater chance of reproducing by itself. Some species reproduce early, increasing the chance of reproduction, but that's not always favorable. So like flies mature very quickly and produce offspring right away. But the quicker a species reproduces offspring, the more likely it's going to die early, because it's putting less energy into survival and more energy into immediate reproduction. And so at some point that might not be favorable, depending on the species, because the longer it survives, the greater the chance that it can reproduce again. And the longer it survives, the more protection, depending on the species, it can give to its offspring. If it's a fly, flies are not really protecting their offspring that much. The whole strategy is grow up and produce offspring as quickly as possible. That is the survive and reproduce. It's less effort on survive and maintaining offspring, but just produce offspring as quickly as possible before you die to increase the chance that offspring have been made, and then as many offspring as possible so that some will keep living. That is the fly survival strategy. So some species, in contrary, take a lot of time to grow and they're providing parental care. So like an elephant is a teenager, an adolescent, until about 17 years old, which is when they reach sexual maturity. And then they don't tend to... Oh, sorry, I'm reading this wrong. They generally reach sexual maturity. Sorry, I didn't remember off the top of my head when elephants reach sexual maturity. I hate to say it. It's pretty similar to human, right? Maybe a little bit different. And they don't begin to mate until that older age. And therefore, the elephant's stronger and it can put more energy into individual offspring. And also, elephants protect their offspring. Don't mess with mama elephant, right? Because they put a lot of energy into protecting their offspring, unlike the fly. And we're, as you can guess, a lot more close to elephants than we are to flies in reproductive strategies. Right? Humans take a long time to develop relative to a lot of species, and a lot of effort is put into individual offspring. Amount of reproductive events. So semelparity is a species reproduces only once during its lifetime and then dies. And often this is species that reproduce like early on in their lives and die, but there's exceptions. We might have bamboo, which can wait many, many years to flower, and then as soon as it does, it dies, which is kind of incredible. But there's also idiroparity, species that reproduce repeatedly during their lives. Okay? So for example, the salmon in A mates once and dies. The antelopes in B mate at specific times during the year, and primates like humans and chimpanzees can mate anytime. Even if it's not the time of the month that they are most likely to have offspring, they can still mate. So I want you to take a minute to read this information on this slide and the next slide, on 49 and 50, about these flies, and then answer this question. So I'll give you a minute to do that. Hopefully you're able to take a minute to look at those questions and read them. And so you should get the answer being C. The greater chance of reproduction leads to selection for this behavior. So you can see that evolution is not just about increasing chance of survival, but also about increasing chance of reproduction. And reproduction means not only the amount of individuals made, but also the chance, in considering the chance of each individual surviving into adulthood. And that is a strategic counter to how long the individuals are going to live. How much energy is put into survival versus how much energy is put into reproduction, and how much energy in terms of reproduction is put into having as many offspring as possible, whereas how much energy is put into protecting offspring. Right? So for example, with humans, a lot of energy is put into survival until a certain age, and then for reproduction, there's a lot of energy for individual offspring, increasing the chance that each individual offspring survives until adulthood, right? So it's a lot different than, let's say, the fish in Finding Nemo that the movie kind of makes fun of by all of them dying, but then pretending that the fish would care so much for the one fish, and very much humanizing them, right? And so when we say survival and reproduction, it's all of these factors. And of course, as we'll get into in a later section, it's not that the fly is thinking, this is my strategy to survive and reproduce, guys. It's not that the elephant is thinking that in an academic sense. They go to academic university and learn about survival and reproduction strategy. No, these are evolved behaviors, evolved strategies. That is it for 36.2.